Hi, I'm Michael, a PhD student in the NLP lab at the University of California, Santa Barbara, and this is our presentation, Modeling Disclosive Transparency in NLP Application Descriptions. So to start, what is disclosive transparency? Well, it's a property of a description of an AI system. Specifically, it is the degree to which a system's description provides detailed messaging about the system to stakeholders such as buyers of the system, users of the system, or the general public at large. However, this notion is often ill-defined and very subjective. This is a problem because disclosive transparency is broadly desired. It's desired by many stakeholders, in particular regulators. For example, consider the European Union. The EU High-Level Expert Group on Artificial Intelligence put out an assessment list for trustworthy artificial intelligence. One of the guidelines that they specify as a regulatory agency is that an AI system's capabilities and limitations should be communicated to practitioners or end users in a manner that's appropriate to the use case at hand. This is a very vague description to give of a regulatory guiding principle. What does an appropriate manner even mean? Furthermore, this can be a problem because disclosive transparency has been shown to have the potential to influence user reactions along many dimensions, including users' understanding of the system, users' perceptions of fairness around decisions made by a system, and users' perceptions of the overall trustworthiness of a system. Unfortunately, these interactions are at present understudied. These studies require a concrete, clear, measurable dependent variable to study, which at present disclosive transparency is not. So, in this work, we set out to resolve this problem. We do this with three things. First, we decompose disclosive transparency into two concrete, graspable concepts. Second, we use this decomposition of transparency to develop three objective measures of disclosive transparency using neural language models. We then demonstrate that these metrics have utility by performing a pilot study analyzing real descriptions of NLP systems. So, to start, how do we do this decomposition? Well, we want to think about what disclosive transparency really means to come up with a decomposition. Fundamentally, disclosure is a communication task around a system, where an explainer is providing some description of a system that they are producing or selling, and they want to convey some information to others. We propose analyzing this disclosure's information in terms of the replicability of the disclosure and the style-appropriateness. Well, what do these mean? For replicability, in concrete terms, we ask the question, does this disclosure contain the necessary information to reproduce the system being described? And for style-appropriateness, we ask, given some specific target audience, and we ask, does this disclosure have a writing style that is understandable to that target demographic? Surely this isn't measurable, but in some domains, we have a lucky proxy where short disclosures, i.e. an abstract compared with long descriptions. System demonstration papers at AI conferences are a great example of a domain where this takes place. So, rather than seeking to recover the true information content behind what is necessary to replicate a system, we treat recovering the text of the full system demonstration paper, which presumably describes in detail how the system functions, as a proxy for replicability of the system itself from the short disclosure. So now that we've established the basis of our analysis, we can now talk about the objective transparency metrics. We produce two measures for modeling the replicability of an abstract. The first we call trigram recovery, which is the percent of trigram information content from the original paper's text that can be recovered by a specially trained GPT-2 model that's trained on an abstract to full text inversion task. The second measure that we propose is called sentence affinity. This is basically a document-level extension of BERT score, which is a sentence similarity metric proposed by Zhang et al. Last year. Here's a diagram showing how this second metric functions. On the x-axis, we have the sentence index from some full article, and on the y-axis we have the maximum BERT score over all sentences in the abstract against the given sentence in the article. As you can see, sentence affinity effectively tracks the degree to which each sentence in the abstract covers the full article text by using BERT score. Similarly, we utilize language models to approximate the style-appropriateness of a disclosure. To do this, we train two GPT-2 models, one on a corpus of academic computer science text from arXiv, and the other on a general corpus of online text. This allows us to approximate the Layman style appropriateness of a description by simply taking the log likelihood ratio of a given passage conditioned on each of those two language models, the academic language model A and the general online text model V. Here's a diagram from the paper that succinctly summarizes all three of the metrics that I just described. With these metrics established, we then moved on to running pilot studies. Specifically, what we want to look at is how do these metrics correlate with actual opinions of real people? How well do our objective replicability and style appropriateness metrics capture the subjective opinions of transparency that are held by both experts and lay people? To answer this question, we conduct two pilot studies using a corpus of 55 demo abstracts that describe potentially end-user-facing systems from recent NLP conferences. To study the subjective opinions of experts, we take 4 NLP doctoral students and ask them to rate, in their opinion, the extent to which each abstract provides task transparency, or in other words, a detailed description of the problem that the system is meant to solve, function transparency, or a detailed description of how the system itself works, and data transparency, or a detailed description of how data for the system is sourced and what happens to user data when they interact with the system. In a similar vein, we assess the subjective opinions of laymen as potential users by having 10 crowd workers look at each abstract and essentially provide answers to questions that fall along this grid, where on one axis we once again have task, function, and data, and on the other we have user understanding, user perception of system fairness, and user trust in the accuracy and privacy preservation of the system. So, what are the results we find? To start, we find that there are indeed statistically significant correlations between the subjective opinions of experts on the transparency of the system descriptions and the objective metrics that are intended to capture transparency. So, for example, this figure shows the correlation between the replicability metrics and data and function transparency ratings as provided by our expert annotators. Similarly, we find that layman opinions on these axes that are related but not directly the same as describing transparency also do respond with our metrics. So, for example, we find that as the style appropriateness to layman increases, the layman perceived understanding of system task and function also increases. Additionally, our metrics have the helpful quality of being somewhat interpretable. For example, the BERT score sentence affinity metric is clearly interpretable. On the up side of this plot, with the left side breakout box, we have an example of an abstract that scores very highly on the system affinity score. It clearly names critical components of the system, such as the SVM ranker, and these lead to high BERT scoring matches to details that are provided in specific sentences in the full paper, whereas the low scoring abstract on the right side only contains very vague and general sentences, and thus does not achieve as high of an average BERT score. So what are the conclusions we can draw? First of all, the pilot study results demonstrate that these metrics are indeed receptive to both expert and layperson opinions of transparency. Additionally, we find that these objective automated metrics for assessing the disclosive transparency of a short description can be applied to study user reactions to systems and disclosures around those systems at scale. We hope to utilize this fact to further develop these tools and apply them to actually study user opinions toward research AI systems, commercial products, and TOS agreements. Thank you.